Leetcode problem 2698, find the punishment number of an integer. So let's try to understand what is the punishment number of this integer. So for example, we are giving an integer n, and the punishment number of n is defined as the sum of the squares of all integers I, such that. So we need to understand basically two things. If we are giving an integer 10, so basically the first condition is that the number should always be more than and equal to 1 and less than and equal to n and less than and equal to 10. So this is going to be the first condition. So the second condition is that the decimal representation of I squared can be partitioned into contiguous subarrays such that the sum of the integer values of this substring is equal to I. Let's just use an example. So for this integer 10, let's just use an example 10. Maybe we're going to use the 10. So the square of 10 going to be 100, and then we're going to try the partition. So the partition is going to be here, 10 plus 0, so it's going to be 10, and 10 going to be equal to this I, so 10 is valid. So finally we're going to plus 10 squared to the final result, so this is a 10 squared, and similarly we're going to plus 9 squared, 81, and plus 1 squared plus 1, so the final result is going to be 182. So if you understand the process of this problem, definitely, maybe we're going to try to use the brute force idea, just to check, because this number n, let's just check this number, because this number maximum is going to be 1000. So this means we're going to use a for loop. This is 1000, and then we're going to check this string. So for the maximum number, it may be, some kind of a million, but we're going to check this string, and then we're going to try to use brute force, like the backtracking, like the partition. We're going to try to check all the partitions if the final result going to equal to this number, maybe 1000. Maybe this is 1000, and this is 0, this is one of the partitions. If this is possible, so definitely, it is true. So the final result is going to plus 1000 square. So I think this is the basic idea. First of all, we're going to use a for loop from 1 to 1001, or from 1 to n, because the first condition, the I going to less than equal to n, and we're going to check all the numbers, and then we're going to use the backtracking to check if there is a possible partition. If there is, so we're going to plus it, the square of this number, to the final result. Now, first of all, let's just define a backtrack function. Maybe let's define it here. Let me just give a pause. Now I'm going to check all the numbers, so it's going to be from 1 to n plus 1. So we're going to check all the numbers from 1 to n plus 1. And before that, let me just define a self.answer. It's going to be false. Now we're going to call the backtracking. So the backtrack going to be, let me also prepare the number. So the number going to be I times I. So inside the backtracking, it's going to be our number. So I'm going to turn the number into a string because I'm going to use the partition. So it's going to be the string num. So I'm going to starting from 0. So I'm going to check if this number 0 going to become the I. So it means it is valid. So after the backtracking, I'm going to check if self.answer is true. This means there must be a valid partition. Now I'm gonna update the final result, so plus equal to num, and finally I'm gonna return the result. So the result is gonna be starting from 0. Now let's just finish the backtracking. So it's gonna be a string, and it's gonna be let me put it a result. So the condition is that if not string, this means the string is not exist, and the result equal to I, it means we've already find it. So we're gonna set the self.answer to true, and we're gonna give a return. So another condition is that if this result is more than I, definitely we can directly give a return. We just let it stop earlier for the backtracking. And now we're going to use an index J to check all the partitions. So normally it's going to be starting from 1 to length of the string plus 1. So this is going to be the positions of the string. So we're going to call the backtrack So inside it's gonna be S, it's gonna be starting from J, and the result gonna plus equal, gonna plus with the integer of the string. So it's gonna come to this J. Yeah. So this is the backtracking. So if it is possible, so definitely self.answer gonna be true. Otherwise, it's gonna still be false. Yeah. So this is the basic idea. Now let me just run it to check. Now as you can see, it works. Now let me just submit it to check if it can pass. Yeah, now as you can see, it passed all testing cases, and I think the speed is okay because this is a backtracking. Even for 1 second, it is still okay. But let's analyze the time complexity. So for here, this n is 1000. It's going to be 10 to the power of 3. This is a for loop. And now we have the backtracking. And for the backtracking, let's just check the length of the string. So the maximum length of the string going to be on 7. And then we're going to check the partitions. How many positions it's going to be maximally. It's going to have 6 positions. So it's going to times, this is a for loop. It's going to check all the possible positions, maybe 6 times 2 to the power of 6. So this is going to be the final result. This is not a big number, that is why it's so fast. I think that's all about this problem. And I think backtracking is not so easy. Maybe the backtracking is the hard part for this problem, but basically this is a good problem. Thank you for watching. See you next time.